We are down to 2 talks. Both of them are going to be absolutely killer. I'm really pleased to introduce the next speaker. Misko and I have been working together as long as I've been at Google, because you were there way before that. You were also at Sun. You were at Xerox.
Yeah.
And where else?
Adobe.
Adobe. Done a little bit of everything. Misko is very active in the open source community, JS Test Driver and Angular, which you're going to hear about today, which is all the rage at Google. We've never been a particularly IDE, we don't do much with IDEs, and we've actually done a lot with this one. And you can too, because it's completely open sourced. Misko is also our kind of agile coach in residence at Google as well. He travels around the company and helps people release faster and do cooler stuff on the web. So I am not going to say anything else. Just give it over to the guy with no shoes.
That's a requirement.
And he also makes the best damn t-shirts in all of Google. Wow. I don't know how to get one. Maybe he'll tell you.
Yes, we have a couple of these fancy t-shirts, and we're going to give them out for good questions. It's a requirement if you work on a project, you do not wear shoes. So all 3 of our developers are shoeless. But let's talk about the project, not about our shoes. So what's Angular? Well, before we talk about what Angular is, I want to kind of set the stage and talk about why are we doing this presentation. And that is that I want to do a call to actions. If you are building a library or framework or whatever else it is that you're sharing with the rest of the world, make sure that that library not just does awesome things, but it also has an awesome testability story. You know, too often, you start building a product, you go out and you look at all these libraries out there, and you start using them, and you say, great, it does exactly what I want, but it's not really testable. And that's a big part. And so one of the things we wanted to make sure when we were building Angular is that testability is something we thought about from very, very beginning all throughout, and it's permeates what Angular is all about. So what is an Angular? Well, it's what an HTML would have been had it been designed for web applications. I know it's a kind of a little vague statement, but if you think about it, HTML really wasn't designed for web applications, right? It was for building static documents, and we kind of hijacked it to turn it into a web app. And I think a demo is easier than talking about it, so let's do a quick demo. So this is a simple application, really nothing fancy about it. You just have a list of phones that run Android operating system. One of the things you can do is, for example, you can search. So you can say, hey, show me all 4G phones, and it automatically searches this. Now, if you think about it, if this is a web application, the kind of things you would have to do, you would have to register listeners over here, and then we have some kind of template for each phone, and as you type stuff here, the template has to be shrunken and expanded, and if I delete, now it has to be expanded back to the original size. Maybe I want to sort this by whether it's newest or alphabetical, right? Nothing fancy over here. It's an AJAX app we have seen millions of times before. But if you think about it, there's quite a lot of code in order to make something as simple as this. And that's because the way the browsers are, it's all about documents, not about the application. And so let me show you the code behind this. What makes Angular possible, this is just the HTML page to bootstrap it. But really, the magic is here. And this is basically it says, if you are a particular route, this is the phone list route. So if the URL ends in /phones, run the phone list controller. And the phone list controller is right over here. If you notice, the only thing the phone list controller does is it says that the current ordering scheme is by age. And the list of phones, well, go find a phone and run a query. And phone is defined in our services basically as, just grab an XHR from this particular URL. I don't want to get into details about how all this stuff works. The point is, it's not a lot of code. And the reason it's not a lot of code is because all of the magic is inside a template, which can do fancy stuff like right here. This is your input box. As you type in here, it automatically, this is the list of phones we got from the controller. And it automatically refilters and changes the list of items. This is just a quick overview of what Angular is and how you can build it. So as you can see, there's very little code to actually make this thing happen. But let's talk about testability, because we are here talking about testing, not about application frameworks. So this is what Angular is. And let's think about how people develop code, right? So first, you got software engineers, and they've read code. And this is true for whether it's a framework or application or anything else. And I made it a big red box because the red represents bugs. And that's where the bugs are put in, right? The developers put the bugs in there. And then we have usually some QA. And they usually run some kind of manual test or exploratory testing. And at some point, they figure out what's wrong with it, and people fix it. And at some point, people say, well, that doesn't really scale, and we need to have automated testing. And so we have to figure out how to get the test to run automatically. And this is really what the conference is all about. How do we do this particular step? So most people start looking for some testing magic at this point. Now, there's a lot of different tools at this level that you can do or you can have. But it turns out that all of these tools have they have value, but they're not the panacea. They're not all that you want. They're just better than nothing. But really, the magic actually doesn't happen here. The magic happens up there. And the magical part is not some special tool, but the way you design your code. In other words, is the application designed with testability in mind? And if it is, the whole testing story looks a lot better than any kind of tool you can bolt on after the fact. And so if you're an application developer, or if you're a library developer, which is even more important, you should have not just the story of what you're solving, but also how are you going to solve the problems of the people who are going to use your library for building tests and tests on them. Now, it turns out testing is a sum of a lot of different things. So first of all, we have the best practices, which is using stuff like global variables, bad idea. A dependency injection, that's a best practice. Having the tools, whether it's Selenium for end-to-end tests or something like JS Test Driver for unit testing. Having the right environment, which is kind of a catch-all. There's not even a good name for this in development world, but really it's all of the pieces that you need in order to write your first line of code. If a new developer comes in, they have to set up whether it's the database, whether it's the IDE, whether it's the tools or servers or deployment strategies. So there's lots of pieces that go into environment. The choices of libraries will affect your testing story. And finally, just knowing how to write a test is what goes into this. And it turns out if you're missing any one of those, you're not really going to have a good testing story. And it turns out that the unit testing story is different from an end-to-end testing story. So while there's a lot of overlap, just because you're an expert at unit testing doesn't automatically make you a test expert of end-to-end. So how can a framework, which is really meant for building AJAX application, help you do better testing? Well, because Angular is very opinionated about the whole building process of an application end-to-end, not just it's a framework for helping you manipulate the DOM so that you can build an application, but it also has a lot to say about the best practices. This is how we think you should set up your application. Because if you follow these guidelines and you set up the application this particular way, you're going to have a much easier time testing this. And one framework that does this particularly well is, for example, Ruby on Rails. Ruby on Rails is a very opinionated framework that says, this is how you set up controllers, this is how you write the unit test, and so on. And they have a pretty good testing culture. So we're trying to do the same thing with our framework as well. We also come with a set of tools, whether it's JS Test Driver for unit testing or our own scenario runner for end-to-end testing. We'll show you in a sec. We also have a ready-made kind of a seed environment for you so that you can get started. And many of the libraries for testability and for third parties we have already chosen because we think these particular libraries fit well into testing story. And so we put all of this information really into a knowledge, and we offer that to you. So let's talk about unit testing story. So the first thing that a library can do for you is just set up the dependencies correctly. So one of the, this is basically what a template would look like, and this is the controller behind this template. And what is very, very subtle here, but makes a huge difference in testability, is that the dependency flows from the UI to the controller. In other words, the controller does not know about the UI. Now, why does that make such a huge difference? Well, it makes a huge difference because if the controller doesn't know about the UI, that means you can instantiate the controller inside of your test without resorting to having HTML present as well. So a very tiny decision in the way you set up your project or the way you choose to implement features of your library has a great impact on the testability story of the application. So by a simple fact that we make this very clear separation between these two parts, we have already enabled a very good unit testing story for you. The other thing that you're going to notice over here is that there is no DOM manipulation in here whatsoever, right? So for example, here where I'm fetching the list of phones from some JSON feed, once I get the response, I simply assign the list of phones into my property and select the default one, the default image for the particular phone. And that's it. I don't go and update the DOM. This Angular is really the magical part, which then goes back and backfills all of the items over here, whether it's a repeater and so on. Now, what would a test look like? Because we can now write a unit test without HTML, this is what our controller looks like over here, and here is a test for it. Notice it's a pretty straightforward test. I wanted to highlight a couple of pieces in green because this is the troublesome part, right? You have a piece of code that talks to a server, but inside of a unit test, there is no server. And so we wanted to make sure that when we allow you to build a web application, we also have a story for you. How do you do this? And the story is that you will do this through, we have mocks for you, basically. So Angular not only comes with you with everything you need to build an application, but we also automatically provide out of the box all of the mocks that you're going to need, whether it's testing XHRs, whether it's navigating for different URLs, and so on. So how do I run it, right? This is the knowledge of what tools do I need. Like this test looks nice and pretty, but unless you can execute this, we're not going anywhere. So first of all, we have chosen what we think is a good testing platform, which is something called Jasmine. How many of you guys have heard Jasmine? How many of you guys like it? Yes? Not so many? Most people? Oh, OK, come on. Jasmine's awesome. And we have a runner, which we have chosen, which is, in this case, JS Test Driver. I might be a little partial to JS Test Driver, but is Corey in the audience? Corey, the man behind the JS Test Driver, back there. So any questions? That's the guy to talk to. And so let me give you a demo of what this particular thing would look like. Oh, so what is the setup? Well, let's do a demo. So the demo is, what happened to, OK, so the way JS Test Driver works is you first start a server, and then you capture the browser. So let's grab this tab over here. Notice the browser gets captured. It becomes green. And the nice thing about it is at the point it's captured, basically you do this once at the beginning of your day. You minimize it, and you never worry about it ever again. Now go to your favorite IDE, and you can execute the test. So let's look at the tests over here. And I can execute the tests very easily, basically by hitting save. And you can see the test execute at the bottom. Now here's the cool part about it. The cool part is when I'm developing, I never had to leave the IDE. So let's cause a failure. Expect true to equal. And I can immediately run it. And you can see that it says, you know, the issue is on line 65, that this particular expectation has failed. Surprise, surprise. But the cool part is that you can really do it on every save. You don't have to leave the IDE. It's built in, right? This is the kind of environment that when I talk about, you know, it's not sufficient to just come up with a testing story. It also has to be that the environment that we give you has to be so that writing the unit test is actually easier than trying to launch an application and doing the. There So what's cool about our unit test? Well, first of all, there's no HTML files, which means that your web developer can go off and start building the UI, and the web designer, who basically creates the UI, can figure these parts later. They're super fast. I forgot to point this out, but look at the timings over here on the bottom. We have executed a whopping of 4 tests. I know it's not a lot, but it took us 5 milliseconds, which means it's an average of 1 test per millisecond. For example, for AngularJS, our framework has about 1,000 tests, and it takes about 2 seconds or so to run 1,000 tests. If you can execute so much code at such a high speed, you can basically run your tests all the time on every save. Now, the reason why the tests are fast is there's several reasons for it. First of all, what's slow in a browser is the DOM manipulation, right? And so our unit tests have no DOM manipulation. Now, there are use cases where you want to test DOM, and we have a different testing story for that. But for unit tests where you simply are trying to prove that the code you have written works properly, the DOM is actually a detriment. The other thing that makes tests slow is talking to servers, but here we have provided you with mocks so that you don't have to talk to the servers, and so you have the full mocking. So all of the tests basically execute synchronously. There's no callbacks inside of our unit tests, so that makes it fast. I haven't showed this, but basically we can execute the test on multiple browsers concurrently. So if you have JS test driver, and I can go in and I can capture as many browsers as I want to get it onto that one server, and then every time I hit save in my IDE, the tests will all run in parallel across all of the browsers, and I will get the report back. And what all of this allows us to do is to run our code on every save. And this is really the magical part, which makes it much easier to work with, do test-driven development, is because the tax of running your tests is so low, is that there's no reason not to do it all the time, right? So it's so cheap to run these tests that I can hook up my IDE to basically run these tests on every time I hit the save key. And the more often you run your tests, the easier it's going to be in terms of finding bugs and issues and realizing when your tests are broken. I showed you a demo. So now that's the unit testing story. Let's talk about the other extreme, which is the end-to-end testing story. So in the end-to-end testing, so in the unit testing story, we basically said, well, we don't want to have any HTML. We're only interested inside of our code. So in end-to-end testing story, we say, well, we actually want to navigate the browser through the full paces so that we basically are pretending to be a user. So we start with a blank browser. We enter some text inside of the URL. We come to a particular page that shows us the list of phones. We enter some text into the search field, and we want to assert that we now only show 2 phones out of them all. And finally, we want to click on a particular phone and go to the detailed view page and then show basically the details for this particular phone. So that's our scenario. This is what we would like to test. So how would that look like? Well, in traditional testing systems, this is the kind of code you would most likely write. This is not the actual code you would write for Angular. I'll show you the actual code in a second. But I want to demonstrate the kinds of issues you might run into. So first of all, you would say, well, go navigate to some URL where the application is running. But now you have a problem. You don't know how much to wait because you don't know how long it will take for the browser to navigate over here. So usually the way people solve this, they have a polling functions, which basically runs every few milliseconds and checks to see if something becomes true. And once this part becomes true, we can execute the second half of the test and basically continue. So now we want to input into the search field some value, and basically we're going to have to trigger an event to simulate that the user has entered. And now we have the same problem again. We don't know how long to wait because it's going to take some time for the UI to update and refresh and all that stuff. And so we, again, have to do a little bit of wait over here. Now, the trouble is if you wait too much, your test becomes slow. If you don't wait enough, your tests become flaky because sometimes you just start running before the tests are really done. So furthermore, we grab the UL, which represents the items. We count that the number of items is 2, and then we find the first item in the list, and we click it. And again, we have the same problem where we have to pull because we don't know how long it will take to transition to the next page, fetch the XHR from the server, and so forth. So the trouble with a test like this, which is a typical end-to-end test, there's two problems with it. First of all, it's not clear how much I have to wait between different pieces. And what comes back to it is that the callbacks are really breaking our thought process, right? People don't think in terms of callbacks. People think of in terms of a list of things they need to do. And so these callbacks, while they're fantastic in terms of what the JavaScript allows us to do with a single thread, they really break our concentration model when we're trying to write a unit test. And so this thing has to be taken care of. The other problem is we don't know how long to either pull or wait for things, and that really affects that the end-to-end tests are usually either slow or flaky. And the cause of this is typically pulling and waiting. And we, of course, need to know when things are done. Now, the framework might know that it's finished doing something, and therefore it's OK to go assert the next step in the test. But it's not really easy to figure this out from something like a WebDriver or Selenium unless the framework is in some way cooperating. And lastly, when we showed you the templates, we had these binding selectors in there, which basically said double curly and said phones dot whatever. But when we were trying to assert that the right data went into the template, we had to use CSS selectors. So we had a discontinuity between what the thought process we had for writing the templates and the thought process we have to have for writing the unit test. So all of these things together make it that it's very difficult to write large-scale sustainable tests in the raw format. And so we have to have solutions for all these pieces. So this is what an actual test looks like in AngularJS, and all of the issues I mentioned a second ago have been solved. So first of all, we navigate to a URL. Notice we simply go and execute the next step, which is we say, well, find me the input which is bound to the query variable, and simply enter some text into it. I don't have to worry about triggering any events. I don't have to figure out where this input is in terms of a CSS. I just need to know that it's the query parameter that it's bound to. Now, the important thing to realize here is that the framework basically figures out on its own how much to wait before running the next step. And it does so because the framework is collaborating with the test runner. And this is an important part, that if you go out and if you build a library or framework, as I said earlier, but you really don't think about testability, simple things like that essentially become death by 1,000 cuts, right? And so when you build your framework for other people to use, you have to think about the whole story, not just solving a particular need. So anyway, so what happens underneath here is that the Angular framework knows when it's busy doing stuff. And basically, when it's finished, it notifies the scenario runner that, hey, I'm done, which means you are free to go and execute the next step in the sequence. So here, and that basically gets rid of all the pulling and all of the callbacks. So next piece is we go and we find our repeater. Again, instead of using CSS selectors, which is not the way you think about the whole process, you can go and use phone in phones. And what these things become, like repeater, input, or enter, it becomes kind of a DSL, or domain-specific language. It becomes the language with which you communicate with your application, right? You don't talk to your application in the low level in terms of CSS and events and so on, but instead you build up something that's meaningful to you. And that, again, helps with the end-to-end testability story, because you really want to make sure that this thing tells a story, right? This has to, it's called a scenario for a reason, because you're trying to describe a scenario, a story to it. And if you have too many callbacks and too many CSS selectors, basically the story gets lost in the details of it. So it's important to have a DSL, as you can see over here. Notice when I, for example, click on something, or here's when I find inside of my phones and I find the first row and I click on the A element, again, a whole bunch of stuff happens over here where we have to fetch XHRs, we have to change HTML templates, we have to compile the templates, and this takes some amount of time before the next step executes. So it's very much simplified for you. So what the scenario runner, so not only do we give you AngularJS, which is the framework for building your application, we also give you a scenario runner for running your scenarios. And what that allows you to do is write async, to turn your async nature of JavaScript into synchronous tests, because that's what fits better for writing unit tests, end-to-end tests. And the result of that is that there's no callbacks. The way this is achieved, as I said earlier, is the Angular exposes specific hooks so that the scenario runner and the framework can collaborate and achieve all these things. So basically, we need to know when things are done. And what that allows you to do is make the tests run faster because they wait just enough time to get the job done, not longer, not shorter. And finally, as I said, it allows you to build up a scenario. So the language by which you're describing what you're doing is very specific to your domain expertise of the application rather than generic CSS selectors and so on. And let's do a demo. So what does that look like? So the same exact application. I can execute. Oh, wait. So as you can see, it's executing, every single step, as you can see, these are the times it took for a particular test, and you can see individual steps, right? So it took 300 milliseconds to navigate to a page, but then asserting things within the page were relatively quickly. But then when I transitioned, actually, it doesn't have a transition. Let's see if I can find the test. Well, I can't find the test. But you would see that there would be a bigger time for the transition pages because those are more expensive. Inside of your code, these tests look straightforward. They look like this. They look very much like unit tests, but really it's an end-to-end testing story. Now, the cool part is that we can also do the same thing for our documentation. So for example, here's a bigger case where this is running actually our documentation end-to-end testing story. So you can see that we're kind of eating our own dog food. OK. Questions? We have some nice T-shirts for questions. Yes, back there. Yes, in the green shirt.
So could you compare what you just described with the scenario runner to what we saw earlier today with the writing tests in plain English? And how do you feel your tests are maintained and are written in plain English versus in a very expressive API, which is what it looks like you have?
So, OK, so there's two parts to it, really. First of all, should you be using written English? So there's, I don't know what tool you're referring to, because unfortunately.
It was the Cucumber thing.
The Cucumber, OK, yeah. Cucumber is an example of that. I think having plain English is very useful because it allows you to tell a much better story. So that's advantageous, but Cucumber by itself doesn't solve the other problem, which is that the framework needs to tell basically Cucumber at which point it's done so that the next step of the scenario can be executed. And so that's the piece that is missing. We simply chose to stay in the language to be consistent throughout the project, to be with JavaScript all the way through. Now, I said that we're opinionated about the way you should test your applications. We're not saying this is the only way. You know, we provided the hooks, we exposed them to you, and you're free to integrate Cucumber into your testing story. But it turns out that most people either haven't heard about Cucumber, or if they heard, they're not exactly sure how all the integration should be done. And even if they have the know-how, it's going to take them some amount of time integrating it. And so the point we're trying to get to is that an application framework or a library should really be available for you to use out of the box, and it should include everything, not just the features that you're trying to do, but also a testing story, the adapters, the environment, and everything you need to know to get going. If you don't like that particular setup, you're free to change it, but it should at least have a setup to get started with. By the way, I like Cucumber. I think it's a great project.
Hi. So you mentioned that Angular can get latencies of all different URLs or whatnot in your user scenarios. Have you tried using Angular for any kind of performance testing for latency measurement? The way LoadRunner or whatever some of the other tools would do?
Yeah, we haven't tried it. We haven't tried using, well, so it's a kind of a multi-level question in there. Angular in itself is a framework for building web applications. You can use Angular comes with the scenario runner, and the scenario runner could be used for latency testing, but we don't have anything out of the box. Probably should add it to the system, but we don't have it just yet. Gail, are you being kind enough to give people t-shirts?
Which one would you like to redesign?
Yes.
Which one do you want? Which one?
So when it comes to jQuery and Angular, can Angular kind of reuse jQuery?
Yes, good question. So if you think about what jQuery is, John Resing, who's really the original author of jQuery, has done a fabulous job of abstracting all the differences between the browsers out. And also he made what's relatively horrendous DOM API into an API that's very easy to use. But if you think about it a little further, jQuery doesn't change the programming model in which you interact with your DOM. You still have to register callbacks. You still have to manipulate the DOM, etc. I like to joke that jQuery shouldn't really exist if the browsers got their job done right. It's really a shim on top of the browsers to make them consistent between each other. But the difference between jQuery and Angular is that Angular raises the level of abstraction to a much higher level. jQuery provides you a very convenient way for selecting DOMs, DOM elements, and updating and deleting them. But at the end of the day, if you wanted to see the demo where I started typing characters and items got removed and added into the DOM, you would have to be the one who would register the listeners. You would have to be the one who would add and remove items into the DOM at the right location at the right time. You would have to be the one merging the model, which is the content of the information about the phone, into the template. And Angular really takes all of that away from you. And the only thing you have to do in Angular is to say, look, here's a bunch of phones I have. Here's the template. There's a directive that basically says ng-repeat, which says, duplicate me for as many phones as there are in a template. And really, I don't want to have anything else to do with it. If I add items into the phone list, the UI should automatically grow. If I subtract items from the phone list, the UI should automatically shrink. And I simply shouldn't have to deal with it. So jQuery and AngularJS is really not a fair comparison because it's really two different things. jQuery is a low-level DOM API, whereas Angular is a higher-level framework specifically for CRUD applications. I think there was a question over here, and then I'll get back. Well, OK, we'll do them out of order.
Can you elaborate around how the test runner and Angular framework talk to each other and figure out when things are done? Because as I see a web app is continuously doing things, so it's not obvious to determine when the next step can be executed.
Right. So AngularJS framework basically sits between the browser and your application code. And all of the events go through Angular framework. So what does it mean? That means all of the XHRs, all of the callbacks from the server, all of the clicks, any interaction with the DOM basically goes through an Angular layer. Therefore, at any given point in time, Angular framework knows if there's any outstanding callbacks in the queue. And if there are outstanding callbacks in the queue, that means that application is not ready. So when the application is booting up and your controller loads and the controller says, go talk to the server and go fetch me the list of phones, because that's a JSON feed, there is an outstanding XHR callback that hasn't been fulfilled yet, and that's how Angular knows that it has to wait. So what the test runner basically does is it simply hooks into the framework, the Angular framework, and so Angular framework has to have an API that it exposes, and it basically says, please let me know when the number of outstanding items is 0, because that's cue to me that I can go to the next step. And so that's basically how that works. And I think there's a question down here.
Yeah, thank you for presentation. Just wanted to clarify some things. Is it like you're trying to create a web application framework, development framework, and you kind of trying to replicate Rails in JavaScript or Java? So all those methodologies and principles, like making a opinionated framework?
Yep.
Just curious, what was the particular goal to reinvent some tools and not to pick up, for example, JBehave together with WebDriver? And what kind of browsers do you support as well? Is your acceptance testing framework?
Okay, a lot of questions. So first of all, easy question. Which browsers we support? Currently, it's IE8 and all the modern browsers. We used to support, the reason we don't support 7 and 6 is not because there's anything fundamentally preventing us, but it's just a pain to work with them. So if somebody really, really wants to support for 7, like, you just have to make sure that things work and it should be there. But anyways, the next question was, why don't you use JBehave?
Why do you reinvent in some tools like a framework to set up your suite and then the driver of the browser?
I'm sorry.
Why do you reinvent some tools like the harness to set up your suite and run it like a test runner? And second thing is the browser driver. It's kind of like, looks like you reinvented them, right, in your framework.
So you're saying, why did we re-implement certain things?
Yeah.
We just wanted to stay in a single language. The framework is really meant for somebody who knows how to write JavaScript. And so we don't really expect that person to have knowledge of maybe Java or Rails or any other framework. So we wanted to be totally agnostic to the world around them. And so we said, well, let's make sure we have a nice end-to-end testing story for the JavaScript world. And so we just wanted to make sure we had the tools for that.
So because and there are no tools for JavaScript like that? Or?
Oh, there are.
OK, cool. Makes sense. Thank you.
And also, you mentioned Rails. Just to compare it, it's true that Angular has been inspired in some ways by Rails. The difference is that Rails is wonderful for building round-trip kind of applications, right? It's all about the server that serves up some piece of HTML, but really all the interesting bits happen on the server. Rails is the same exact idea, but I'm sorry, Angular is the same, very similar idea, but it's all about the client, where the whole application is in the client, and we're really actually completely agnostic about what the server has. So we're just plagiarizing other people's wonderful ideas and just turning them where the browser is the center of the world.
So I love the non-waiting, the automatically waits until kind of all the XHR is done and stuff. But with all magic, occasionally you want to sidestep the magic. Like if you're testing ads on YouTube, you don't want to have to wait for the whole YouTube video to download before you can check stuff in the ads. So are there ways of kind of sidestepping the beautiful magic that it does?
Absolutely. That would require us to go too much deeper into the internals of how the whole thing works. But basically what happens is when you write the synchronous code, so there's no way to write synchronous code in JavaScript, right? Everything's always async. So what's actually happening is what the DSL is the DSL builds up an internal state machine of what to do in terms of testing, and then the state machine executes in a synchronous manner, and the state machine transitions when the right stuff happens. And this is done through futures, and so you can register just the right kind of futures into the system, and then you can transition the state machine at your own time. Really, the synchronous DSL is just syntactic sugar for programming, you could think of it, the state machine. That's all we have time for? All right. Thank you, guys. Check it out. And
just one question, please.
Yeah. Oh, just for you, one more question.
Thank you. This was more regarding the implementation part. I understand that we could probably have the developers working on Angular, making all the coding activity, and then also running the unit tests from the Angular itself. That part is clear, unit testing part. But when you talk about end-to-end testing, are we expecting the testers or one who is doing the end-to-end testing to also work on Angular? Am I clear?
So your question is, are the end-to-end testers expected to know how to program Angular?
Yes. Because
no, not necessarily, because the DSL that is created inside of the scenario runner is much simplified. And so you don't have to have the internal knowledge of Angular or JavaScript or anything like that to be able to write one of these things. Also, if somebody would integrate Cucumber, which is very much possible, then it would be even further, less like a code and more like cut and paste these strings in the following sequence, and then the world works.
Okay.
You can catch me after the presentation. I'm happy to talk more.
Are you going to stay on for beer and brats?
Later on, yes.
All right, great. Well, thank you very much, Misko.
Thank you.